Alright, time for another measurement. In this one, we're going to be measuring the piston diameter, sometimes called the thrust face OD, and OD for outside diameter. And when we do this, we're going to need a bigger micrometer now because we're dealing with a larger object. This is where knowing your specifications ahead of time can help you out a little bit. So for example, I know that this piston should be about 2.125 inches or 2 125,000ths of an inch in diameter. Okay? Because of that, I automatically know I need to grab a 2 to 3 inch micrometer. When we measure the piston diameter, we have to measure it in a specific location. It might be hard to see with the naked eye, but not all pistons are exactly round at room temperature. Some pistons are narrower across the diameter where the pin bosses are and wider by the slipper skirt diameters. Okay? And the idea behind that is the material distribution inside of the piston is uneven. So as the piston heats up, it's going to expand and become round, even if it's not. As well as the top of the piston here is the floor of your combustion chamber. So the top of the piston is going to run a lot hotter than the lower part of your skirt. Therefore, more room is given for thermal expansion near the top of the piston. So the diameter at the top near the ring lands is not necessarily the same as it is near the bottom of your skirt. So some engines it's more crucial than others, and other engines are different on where they tell you to measure it. Some of them will even specify how far from the bottom of the piston you should be measuring your diameter. But as a general rule, you want to measure the pistons near the bottom of their skirt and probably within about 5 to 10 millimeters of the bottom of the skirt across, and you want to measure this perpendicular or 90 degrees from the wrist pin bore. So I'm currently holding the piston where I would want to take my diameter measurement with it, with my micrometer. Okay? I found that the easiest way to do that is to set the piston on its head, and because we are not engaging in a super precise high performance engine build, we're not going to measure and mark out the height from the bottom of the piston skirt to take a measurement. We're going to approximate it. So turning it upside down on a workbench, I'm going to take my micrometer and I'm going to hold it approximately 10 millimeters or so from the bottom of the piston skirt, which is currently facing up, and using the ratchet mechanism on the micrometer, I'm going to bring the micrometer against the part, and I'm going to rock it, and I'm going to try to rotate it gently to make sure that I've got the spindle and the anvil nice and flat on the skirts. Okay? If my ratchet starts to click, my micrometer is more than tight enough. Any much more than that, I risk damaging my piston, as well as it's not really needed for the micrometer to go that tight. And then what I will do is I will just give this a quick test to make sure that it slides. And when I do this, I want to be very careful. I don't put a lot of force into it, because if I'm not straight, or if the edge of my anvil, or my spindle dig into the skirt, it can damage the skirt. Remember, these piston skirts are aluminum, so it's a pretty soft material. And on most of my micrometers here in the shop, the tip of the spindle and the anvil are usually carbide or carbide tipped, and so they hold a really nice sharp edge for a very long time, and we don't want that digging into the skirt, damaging it. Now that I've got my reading, I can bring this up, see if I can get it to focus for a reading. And if we take a look, I'm 2 and 100 plus 24, so 2 124. And then check my vernier scale. Come on, stay in focus. And I will call that a 1. This my micrometer has gotten a little bit old and hasn't aged very well, but we're going to say that's a 1. So that'd be 2 and 1,241 10,000ths of an inch. Okay, we'll take that measurement. We'll record that in our packet under piston diameter found. We'll compare it against the specifications, which you're going to transfer from the list on the column in the shop. And then you're going to determine whether or not your piston is within spec or out of spec. And then come find me for a checkpoint. Now, when looking at the numbers here, we're measuring an outside diameter. Okay? If your measurement is less than the minimum specification, there's two main things that may have happened. One, you mismeasured and you measured a chord and not the diameter. Okay? Or two, your piston skirt might be collapsed and your piston might need replacing. I suppose the third option would be is your micrometer is out of calibration, or some other aspect of your micrometer technique needs to be addressed. But we'll go ahead and assume at this point in our measurement and inspection process you're fairly proficient at the micrometer, and you remember to check your micrometer before every measurement. So take a look at that. If it's slightly larger than spec, because it's a brand new engine, that would be interesting to see. However, if this was a used engine, there are possibilities that you could be measuring an oversized piston if the engine's been serviced once before. Typically when that happens, the amount of oversizing is stamped into the top of the piston. Granted, if it's had a bunch of hours on it, it could be covered with carbon. But just FYI on that. Okay, any other questions? Hopefully that answered a few ahead of time. If there are any other questions, come find me in the lab. And thanks for watching.